Hey guys, it's Miss Johnson and I'm back to bring us the rest of the notes on solving systems by elimination. So we talked yesterday about solving systems using elimination where we were trying to get rid of one of the variables. Now today we're going to do a little bit more with that. We're still lining them up in standard form. We're still canceling out one of the variables, but now we're going to have an extra step to take care of or to fix our equations. So let's just take a look at those steps at the top of your second page of notes. Steps to solving using elimination. Again, you're probably going to have to write kind of small in that box, just to let you know. The first step, make sure you have both equations in standard form. That's where we have that ax plus by equals c. Ax plus by equals c. You need the x terms and y terms together on the left and the constant over there on the right. Okay. After you put both equations in standard form, then now we're going to have to do some multiplying today. We're going to have to multiply one or sometimes both of the equations by some number so that one of the variables has opposite coefficients. This is what you're looking for. You want opposite coefficients. That's the key there. Opposite coefficients, meaning, for example, -3 and 3. That's what opposite coefficients are. They need to be one positive, one negative of the same number. It could be -10 and 10. It could be -6,000 and +6,000. It doesn't matter what it is, they just need to be opposites. Then the good news is the last three steps are the same as what you did yesterday. Add the two equations together, one variable should cancel, solve for the remaining variable, substitute that in and get the other one. Okay, so it's really just these first two that are new for us today that are going to be a little bit of an extension of that elimination method. So let's take a look at some examples. In number 1, we have x plus 2y is equal to 10, and in the bottom, x plus y is equal to 6. Now, we did a little bit of this yesterday where we had to multiply one of the equations by -1. I've got my x terms lined up, y terms lined up, equal signs constant, I'm good. But I don't have opposite coefficients. So if I take this bottom equation and I multiply it by -1, in other words, distribute a -1 through all of those, here's what the new system looks like. X plus 2y equals 10 on the top didn't change. But on the bottom, -x minus y equals -6, that's now a new equation. Now I have opposite coefficients, 1 and -1. So I have +1, -1, now I'm ready to add them together. When I add them together, 1 minus 1 goes away. Then I have 2y minus y, which is just y, and 10 minus 6, which is 4. Y is equal to 4. Then, just like yesterday, we take that and we plug it in to get the other half. So I'd have x plus 2 times 4 equals 10. That gives me x plus 8 is equal to 10. Subtract the 8, and I get x is equal to 2. So my solution to the system is 2, 4. Now, if you'll notice, this ended up being the exact same system as it was in number 1 on the first page. It's just that these were both positive x's, so we had to take care of that. Okay, let's take a look at number 2. In number 2, I have 2x plus y is equal to 4, and 3x plus y is equal to 8. So no opposite coefficients again. Here's 2 and 3, here's 1 and 1, and 4 and 8 are constants. We don't want those to change anyways, or we don't need to worry about those. We need to worry about the variables. But in this case, I don't have anything that's opposite. So again, I'm going to multiply this top equation by -1. It doesn't matter which one I pick here because I just need one of the y's to change to negative. So I fix that. That's -2x minus y is equal to -4. The bottom equation I'm going to keep the same. 3x plus y equals 8. Then add them up because now my x terms go away. -2x plus 3x is x. -4 plus 8 is 4. So I have x equals 4. Then I plug it back in. 2 times 4 plus y equals 4. That's 8 plus y equals 4. And subtract the 8. Y is equal to -4. So now here's my solution. I have 4, comma, -4. Okay, let's try number 3. In number 3, I have 2x minus 3y is equal to 11, 2x plus 2y is equal to 6. I notice that the x terms have the same coefficient, it's just that they're both positive. I need one of them to be negative. So again, I'm going to distribute a negative 1 through the bottom equation. It doesn't matter which one I pick because I just need it to be negative. So the top equation I'm going to leave the same. 2x minus 3y equals 11. On the bottom, negative 2x minus 2y is equal to negative 6. Add them up. Your x terms drop out. You have negative 3y and negative 2y, which is negative 5y. And you have 11 minus 6, which is 5. Divide by negative 5, and you get y equals negative 1. Plug it back in to get the x. 2x minus 3 times negative 1 is equal to 11. That's 2x plus 3 is equal to 11. Subtract the 3. All of this solving equation stuff is stuff that you've done many, many times before. And then I just get x is equal to 4. So here's my solution. I have 4 comma negative 1. All right, I'm going to skip number 4 for now, and I'm going to move on to number 5. We'll come back to number 4 and do that in class together. So let's take a look at number 5. Now in number 5, I have 6m plus 3n is equal to 3, and m minus n is equal to 8. Now I have all my variables and my equal signs lined up, m's, n's, equal sign, constants, they're all together. But what I notice is the coefficients here are 6 and 1, and 3 and negative 1. Now you have two choices, okay? I need to either make this m down here a negative 6, or I need to make this n a negative 3. Now it doesn't matter which one you do, but since this n is already negative, I'm going to choose the n to get rid of, which means I need to multiply this bottom equation by 3. Because if I do 3 times negative 1, that gives me negative 3, which then cancels the positive 3. So the top equation I'm going to leave the same. 6m plus 3n is equal to 3. The bottom equation, I distribute that all the way through, even across the equal sign. So that's 3m minus 3n is equal to 24. And now let's take a look at what happens when we add them together. When I add these together, my 3 and negative 3 goes away. I have 6m and 3m, which is 9m. And over here, 3 plus 24 is 27. And then divide by the 9. And m is equal to 3. Now I've got my m variable, I can plug it back in to get the n variable. If I use the bottom equation, I'd have 3 minus n is equal to 8. Subtract the 3. That's negative n is equal to 5. And divide by the negative 1, I get n is equal to negative 5. So my solution here, again, we always go in alphabetical order, so it would be m first, which is 3, then n, which is negative 5. 3, negative 5 is my solution. All right, we're going to go ahead and stop the video here at this point. Please hop back to Schoology and take that quiz for me, and I will see you all later. Have a good night.